Minimum travel time fire spread is driven by a flame app, MTT, and it's also the same model as short term in WFDS. MTT Fire Spread allows you to view fire spread and travel through a landscape based on an ignition and a static set of fuel moisture parameters. This can be really useful if you're comparing treatment alternative locations or effectiveness and their impact on fire spread. To run MTT Fire Spread in IFTDIS, you can navigate to the playground directly from the top navigation, or if you're in the cycle and see a model fire behavior tile, you can get to the playground that way as well. From playground, we use select model to run, and from the drop-down menu, select MTT Fire Spread and click Create Run. If I didn't have a landscape already, I could create one here using the Create New Landscape button. But we do have a landscape in this drop-down menu, and that drop-down will select all available landscapes that you created or uploaded to IFTDIS. For wind inputs, we can choose gridded winds, static, wind blowing uphill, wind blowing downhill. The differences between these are described in the Help Center. I'll go with gridded winds, which uses Wind Ninja to adjust the wind based on landscape topography. It will specify a 20-foot wind speed in miles per hour and wind direction. Crown fire method, I'll leave Scott and Reinhardt, which is the default. We could select Finney here if we wanted. I'll also leave foliar moisture content at 100%, but that is another field we could change. For initial fuel moisture, I'll set the 1, 10, and 100-hour fuel moistures, as well as herbaceous and woody fuel moisture. And I'll leave this as is, so it applies these fuel moistures across the landscape. If I wanted to apply different fuel moistures to different fire behavior fuel models, we could do that by adding a row and selecting a specific fuel model and calling out that fuel moisture for it. So I'll go ahead and delete this extra row. Fuel moisture conditioning will adjust these fuel moistures based on topography and weather. We can choose not to condition, which will apply the same fuel moistures across the entire landscape. We can condition them based on default weather streams in IFTDIS. Right now, extreme weather is the only one available, but if we had our own weather stream data, we could import that as well. Ignition, any point, line, or polygon that intersects our landscape will be available in this drop-down menu. I don't really want to use any of these at the moment though. This is very responsive, so we can go ahead and create an ignition here on our map and use it in that field. To do that, I'll select Create Edit Shapes. For this case, I'll draw a line. We'll just draw a line north of this road. Give it a name and select Create. So we can see it's been drawn on the map. And if I go to the ignition dropdown, it's now available here for us to select. Barrier is an optional input. We can choose to use a barrier or not. For this example, I won't use one. But there are use cases where a barrier could be beneficial. For example, if you have a road or body of water going through your landscape that might not be captured in the landscape file or the landscape fuel models, you can use a barrier to help ensure that it is treated as a barrier in the fire model. For simulation time, we can choose the time of fire growth, both in terms of hours and burn periods. We can select up to 5 burn periods. Spotting is addressed in Help Center. We have a default spotting probability of 20%, and that's generally recommended, although you can change this if you have a specific preference for spotting probability. Notes, we can just add a note here that'll display in the metadata if we're working with this later in my workspace. Sometimes it's helpful to have a little bit of background information on the landscape. We have all our required inputs, so I'll go ahead and give this a descriptive name and click Run. We can see confirmation that the model has been submitted. And if we click out of that, we're taken back to Playground. We can see that it's been submitted, and we can use the refresh button to check its progress. With our MTT model completed, we can view the file options and select View on Map to see the results. This will show the fire spread results geospatially. By default, the MTT arrival time feature is turned on, and this corresponds to our burn periods. In this case, I'd selected 3 burn periods. So we've got period 1, periods 2 and 3. We've also got the arrival time contours as well, in addition to a raster version of our ignition line. If we had barriers, we'd also have a raster version of those. And I can also toggle arrival time off and turn on rates of spread, or toggle fire line intensity. So we can see where an output like this would be pretty useful for determining treatment effectiveness by location or treatment type on fire spread. And one other output, it's grayed out right now, but if we're zoomed in, we'll be able to see it, and that is the MTT major pathways. So that'll show the major pathways for the MTT run. And you'll generally have to zoom into this because once it's zoomed out, these lines get pretty hard to detect. And if I navigate to my workspace, we can see our model is stored here. If we wanted to use an output of this in some other system, we can download a copy of this model output. And in that output package, we'll have a multi-band geotiff, the arrival time contours, barrier shapefile if a barrier was used, as well as ember and ignition shapefiles, major flow paths, symbology layer files, so you can replicate the same symbology in ARC as we have in IFTDIS, and a fire modeling services framework input file. In addition to viewing the outputs geospatially in Map Studio, we can also request a report to view those outputs quantitatively with graphs and tables. So here we can see a summary report for our MTT model outputs, and all of these graphs and tables are downloadable. We've got arrival time, fire line intensity, and rate of spread components in this report. And you can also download a PDF version of the entire report using the Download Report option in the top right. And when you create a report, that is also stored in my workspace in the same folder as the output it was created from. So that is a very brief rundown of the minimum travel time fire spread model.